For your notes in your composition notebook, you should be writing Chapter 1, Section 3, Communicating with Graphs. And the main idea for this section is graphs are visual representations of numerical data that help scientists detect patterns. A graph is a visual display of information or data. This is a graph that shows the motion that takes place when a girl takes her dog for a walk. Notice, and please draw the graph. You'll just draw a box. You don't have to take time making all the lines. First of all, you need a title, and this title says distance from home. On this side, we have written distance, and at the bottom, we have written time. Take a moment to do that. Drawing a line from distance and create your own box in your notes, write down the dependent variable in this graph is distance because it's what we're measuring. And at the bottom of time, draw a little arrow, make your own little bubble box. The independent variable in this graph is time. It's what we're changing or what we're testing. The horizontal axis or the x-axis measures time. Time is the independent variable because as it changes, it affects the measure of another variable. The distance from home that a girl and the dog walk is the other variable. It is the dependent variable, and it's what's measured on the vertical axis or the y-axis. Another way to remember that is when we do an experiment, what are we measuring or what are we wanting to find out? The y. So the y is over here on the left where your dependent variable goes. There's all different kinds of graphs. In this case, we're going to be talking about the line graph, bar graph, and circle graph. These are appropriate for displaying different types of information. So for example, a line graph can show any relationship where the dependent variable changes due to a change in the independent variable. Line graphs often show how a relationship between variables changes over time. What does that mean? Well, think about social studies. What's one of the first things that you start learning about? A timeline, right? Events as they occur over amount of time. Well, in science, a line graph is much the same thing. It's a historical graph of how things are changing over a set distance of time. So notice the break in the vertical axis between 0 and 15 means that the numbers in this range are left out. This leaves room to spread the scale where the data points lie, making the graph easier to read. Okay, so in our graph, when setting it up, we always go from left to right and from top to bottom using equal parts. So here they're going by 5s, and here they're going by 1s, 18, 19, 20. Okay, they've also scheduled their graph in different colors. You have line A, line B, and line C. Display data on the line graphs. You can show more than one event on the same graph as long as the relationship between the variables is identical. Suppose a builder had 3 choices of thermostats for a new school. He wanted to test them to know which was the best brand to install throughout the building. He installed a different thermostat in classrooms A, B, and C, and he recorded his data in the table. Students, you should be writing down this entire slide, including this part. The builder then plotted the data on a graph. He could see from the table that the data did not vary much for the 3 classrooms, so he chose small intervals for the y-axis and left part of the scale out, the part between 0 and 15. This allowed him to spread out the area on the graph where the data points lie. You can see easily the contrast in the colors of the 3 lines and their relationship to the black horizontal line. The black line represents the thermostat setting and is a control. The most important factor in making a line graph is always using the x-axis, right here, for the independent variable. The y-axis is always used for the dependent variable when making a graph. Another factor in constructing a graph involves units of measurement. You might use a Celsius thermometer for one part of your experiment and a Fahrenheit thermometer for another. You must convert your temperature readings to the same unit of measurement before you make your graph. Scientists use a variety of tools such as computers and graphing calculators to help them draw graphs. Okay, what I need you to write down here is bar graph, and that it's used for comparing information collected by counting. You'll want to make sure you draw out this data chart, please. And you don't need to write this bullet point down. For example, suppose you counted the number of students in every classroom in your school on a particular day and organized your data in a table. This is what it would look like in a bar graph. You could show these data in a bar graph as on a line graph. The independent variable is plotted on the x-axis and the dependent variable is plotted on the y-axis. Another way I can remember that is if I make an x, where does the bottom of my x? It's right here, okay, the 2 points from the x. And if I make a y, I have one line and it moves to the left. Just another little helpful tip there. Okay, circle graphs. It's a pie graph. Okay, we use this to show how some fixed quantity is broken down into parts. And notice that this pie represents a total. Okay, the slices represent the parts and are usually represented as percentages. This figure illustrates how a circle graph could be used to show the percentage of buildings in a neighborhood using each of the variety of fuels. To create a circle graph, you start with the total of what you are analyzing. This graph starts with 72 buildings in the neighborhood. For each type of heating fuel, you divide the number of buildings using each type of fuel by the total of 72. You then multiply that decimal by 360 degrees to determine the angle that the decimal makes in the circle. 18 buildings use steam. Therefore, 18 divided by 72 times 360 equals 90 degrees on the circle graph. You would then measure 90 degrees on the circle with your protractor to show 25%. For your morning reviews, essential questions: what are the 3 types of graphs and how are they used? How are dependent and independent variables expressed in a graph, meaning where are those going to be? And how can you analyze data using the various types of graph?